Hey everybody, so we're going to go over the second assignment in regards to angle measure worksheet, or angle measure rather. So it's very similar to the first one, so let's get right to it. So this asks us to name the vertex of each angle. Angle 5 is here. The vertex is the common endpoint for the rays that form said angle, so it'd be point M. Angle 3, which is down here, that's the vertex right there. You got the angle coming out of, the two rays coming out of that common endpoint, so point P. Angle 8, right here, that's going to be vertex O, and then NMP. So NMP, the middle letter actually here will always be the vertex. If you're looking at a name of an angle and you have to identify the vertex, it'll always be that middle letter, which represents the point. Okay, name the sides of each angle. So sides are going to be the rays that form an angle. So angle 6, this is a side, and this is a side, so NM and NO. We have to be careful of our notation, make sure we keep it accurate. Oh, what am I doing? As I can proceed to screw it up there. All right, so NM and NO. Angle 2 down here, so we have PM and PR. So PM and PR. MOP, so here, so side, so OM and OP. OM and OP. And then OMN, so OMN, so here, so this side and this side, so MO and MN. Mo and N. Okay. All right. We'll write another name for each angle. So QPR, Queens Park Rangers. So QPR here, another name for that angle. Well, there's no number attached to it. Sorry, QPR is here. My bad. I was looking at the O. So QPR is right here. So this is the angle. We can name it angle 3, or we could also name it angle RPQ. We cannot call it angle P because there's already other angles there. So we're with angle 3, or we can go with angle RPQ. Okay. Angle 1, which is right here. So OPM or MPO, we can call it. I mean, those are the only two options. So OPM, angle OPM, or angle MPO. Okay, let's scroll down here. So we got to name these angles. Wait, actually, I have to identify these angles. So it's either going to be right, acute, or obtuse. As a reminder, right is 90 degrees. Acute is less than 90, greater than 0, and obtuse is greater than 90, less than 80. So UZW. UZW is right here. That is a right angle. We know that because of the notation of this box. So this would be right. YZW. So YZW is here. Now, this is an interesting one. So because this is 90, these two angles add up to 90. That means these three angles add up to 90. Okay? Because we know the entirety of this would be 180 degrees because it's a straight angle. So because these two add up to 90, I'll say it again, that means these three have to add up to 90 together. Okay? That means individually they're less than 90. Okay, so YZW. So YZW, so these two, well, we know they're less than 90 total because we know the three have to add up to 90. So by definition, it'd have to be acute. TZW, so we know this is 90. We know this is more, well, this is another, basically this is more than 1. So more than 0, rather. So this has to be greater than 90. Therefore, it has to be obtuse when it's combined together. And then UZT. UZT is the smaller angle here. We know that's going to be acute because we know the three have to add up to 90. So acute. So that's the first page. And let's look at the second page here. So, okay, we see it that way? Yeah, here we go. Let's check out the notation here. So we have in the figure rays CB and rays CD. Okay, these are opposite rays, therefore they form a straight angle. Okay, in other words, they form a line. Ray CE, so this is C, bisects DCF. So this is DCF. So this bisects it. That means it creates two congruent angles. Okay, that's what this does because it bisects it. And then CG bisects FCB. So that means these, I'll use a different color. These are going to be congruent as well. Okay, so, all right, that's important. So if the measure of DCE, which is this one, is 4x plus 15, and ECF, which is this one, ECF, is 6x minus 5, find DCE. DCE is this one. Okay, so we know these are congruent because this bisected the larger angle. So because they're congruent, we can set these equal to each other and solve this algebraically. So we're going to say 4x plus 15 is equal to 6x minus 5. And we're going to solve for x. So let's get the x's on the same side. Actually, I'll zoom in a little bit here since, oh, I'll keep it like that. We're going to subtract 4x from both sides. And we're going to get 15 equals 2x minus 5. And then we're going to get x by itself. So we're going to add 5 to both sides. And we're going to have 2x equals 20. And then we're going to divide both sides by the coefficient, which is 2. And x will be equal to 10. Yeah, we'll go 10. Sounds good. Let's just check that, see if that works. So 4 times 10 is 40. 40 plus 15 is 55. That works. 6 times 10 is 60. 60 minus 5 is 55. So yeah, they're the same. That worked. Cool. All right, and the last one. And by the way, it's assumed that these conditions are down here as well. So I'm just going to write the notation so we don't get confused. Okay. So FCG, which is this angle here, is 9x plus 3. I'll keep it blue. So 9x plus 3. And then GCB, which is this other angle here, is going to be 13x minus 9. Okay. And it's asking us to find G. Oh, hold on. Let's back up here. I actually messed up. So we found x, but it's asking us to find DCE. So I made a big mistake there. Whenever you're solving these, make sure you are careful to identify what they want you to solve. It's very easy to stop at the variable like I just did. And the only reason I caught myself is because when I read the second problem, I read that again. So let's not fall for the thing I just did. So DCE. So DCE is this angle here, and we already found that it's 55. Let's just show the work, though. So 4 times x plus 15. And then 4 times 10 plus 15, 40 plus 15, 55 degrees. So that's what we're looking for. The measure of angle DCE is right there. Okay. So down here, we're going to solve this the exact same way. We're going to set them equal to each other because we know this bisects the larger angle. So we're just going to solve this algebraically. So we're going to say 9x plus 3 is equal to 13x minus 9. And we're going to solve for x. So let's get the x's on the same side. We're going to subtract 9x from both sides. And that's going to be 3 equals 4x minus 9. Let's get rid of that constant. So we're going to add 9 to both sides. 12 equals 4x. And then we're going to divide both sides by the coefficient. So we're going to get x is equal to 3. So we're not going to fall for that trap again, right? We're not done, so we need to find GCB. So GCB was 13x minus 9. So 13x minus 9. And then we're going to plug in our x value, which in this case is 3. And 13 times 3 is 39. 39 minus 9 is 30 degrees. Let's see if that works. So 3 times 9 is 27. 27 plus 3 is 30. Yeah, that works. Awesome. Okay, so some takeaways. Make sure you don't make the mistake I did. Make sure you read the problem clearly, and probably twice at least, and double check that you found the right thing. Okay, so that's the second page. That's the first page. Hopefully that was helpful. Thanks, guys.